Hello, it is 12:07. I'm a little bit late getting started today. I live in a house with two other grown-ups and a dog and a cat and a baby. And both of those other grown-ups work from home remotely and are 100% of the time, at least one of them is on a call, and there's just a lot of noise in the background. So I wanted to spend it took me a little bit of time to get things set up so that there wasn't too much background noise, because I don't want to accidentally be recording all of my partner and housemates' work calls and streaming them to the internet. That seems bad. So I think I solved that problem. So everything is a hunky dory now, and so hello, hello. Welcome to episode three of Built from Scratch, the Scratch game development educational coding live stream that nobody asked for. In this series, we're going to be going 1 hour at a time, one day at a time. We're going to be building a video game, piece by piece, all live, all in Scratch. Here, all and you can see every piece of it. You will see every line of code, every block of code that I write, every bit of thinking I do on this game, I am broadcasting. So that hopefully that provides a interesting, if not an interesting viewing experience, at least an interesting educational resource for showing you how one might go about taking all the little pieces that go into a software project and integrating them into something big. I am sometimes a teacher, sometimes a software developer, so I feel like there's something, and in my experience, one of the things that people find hardest about coding and learning to code is integrating the parts of a project into a whole. Usually, when you get started learning or get started working on something, you work for a little while and you keep adding new things, and it's super cool and super fun and super exciting, and you're making all this amazing progress, and you feel so good. You feel so good because it's every day you sit down and you just bang out a feature, and then you wrist another one, and you make it, and you just go down this checklist, and then you hit this wall where the next time you try to code something up, you sit down to look at your code and you say, if I'm going to make this feature, I'm going to have to change this thing, and that's going to touch this other part of the code, and it's bad. It gets bad, and then that's usually when you abandon the project and, stop your recreational coding for a couple of months and then start something new a couple of months later. So I want to just, at the moment we're still in that really early, just every day we are going to make new stuff and it's going to be awesome phase. But over time, we're going to have to figure out how all the code that we are writing fits together in one cohesive whole. And so, and that's something that is hard to see except by doing it. And so I hope that by doing it live on air, a little bit at a time here, I can share with you some of that thinking and some of that thought process and some of how that works. So that is the goal, that's the plan, that's the hope, that's the dream. Here we are, getting ready to do it. I think I have closed all of my windows, and will not have any horrifying notifications. Here, let me just check that I closed work Slack and all the other Slacks, and yep, okay, cool. Nothing is open, I think, so I think I will not accidentally dox myself or any colleagues, and everything will be awesome. That said, I guess I'll hop into full screen mode so that you can see a little bit more of the screen here, and we will think about what we are doing. So here I am. I am built from Scratch, so it's the same username on Scratch as I have on Twitch. So if you are interested in following along or snagging any of this code and building something of your own off of it, that's super cool. I would be super thrilled to see any remixes or work that you make. So please do that if you're watching and that sounds fun, or if you just want to kind of snag the code and look at it, get a sense of how the game is coming together. So you can follow along. That's great too. You can go to the Scratch website and search for this username built from scratch, and you will see all of my shared projects here, right? So we have two, right? Because I accidentally didn't save the middle one. We have these two from the test streams, and then we have our 2 episodes here, 1 and 2. I'm going to go to episode 2, scrolling the galaxy. I'm going to see inside, and before I do anything else, I'm going to copy this. So I'm going to save as a copy, and I'm going to just put a 3 here for now, and maybe some question marks, because we'll see exactly what we get to. If you recall from the last time, what we did here, let me hide these reporters. Let's not delete the player ship. That would be a good thing. I'm gonna hide. Let's see, it's the camera. I'm gonna hide these camera variable reporters because I don't want to see that. And I want to run this program. So at the moment we have 3 sprites. We have a player ship, which has the main code for this. Here, let me rearrange. Let me just stretch out a little bit. Okay, good. So, all right, there we go. Okay, so the main code for this player sprite is in this loop, and I'm gonna call this my game loop, because it's a very normal kind of structure and design pattern for game development, where you have a loop that does a bunch of things over and over again, right? We take input from the keyboard or from the player. It might be mouse input, it might be other kinds. We could make it sound controlled or all sorts of craziness if we wanted to. Video motion controlled. Scratch can do all that stuff, which is pretty fun. But for now, we accept input from the user. We process that input in some way. At the moment, it's just our little physics, what I'm calling our physics simulation. But we probably, will have other layers of input processing as well, other kinds of game logic. And then I have this, go to XY. And this is kind of a funny, this block that says go to XY with these things, that is just telling our sprite where to be on the screen. So this is like input, processing, and then telling the sprite where to be on the screen. So I'm going to think of that as like drawing or rendering. So if you were using a more traditional video game engine, game programming paradigm, there would be this what's called the rendering step, where you take all the information about where all the sprites are, where all the objects are. You might be in 2D, might be in 3D, and somehow you take that information and you turn it into some instructions about where to draw pixels on the screen. And so for Scratch, which handles most of that for us, this single go-to block currently is our whole rendering layer, but we might have more. We might have more rendering stuff for the player or other things in there as well. And actually, I'm just going to point this out. I'm not as like a potential wrinkle, a potential problem. I would just point out that in this handle input, I do this switch costume here, switch costume thrusters on, thrusters off. Having this switching of the costume inside of the handle input is like a little bit dubious, because in some philosophical sense, picking what costume the player ship has should really be thought of as part of the drawing or rendering step. It may eventually be useful or important to pull that out and make, kind of combine them into one step. If that's the case, great, we'll do that. That won't be hard. We're not going to be locked into some kind of like philosophical framework where we say, where we accidentally end up adding complexity to our program by trying to fit some arbitrary ideals. But I do want to note that this is potentially it's a little bit iffy. It's a little bit, I don't know. But that's okay. So, sorry, I was going over the game loop. We have handle input physics and go to XY, which is like be drawn on the screen. Input physics draw. What does input do? It checks if the up arrow key is pressed, turns the thruster on. Turning the thruster on means applying a force, which means changing a speed, right? For that's, if you are into your physics 101, that's more or less what applying a force is. It's changing, creating applying a force is changing an acceleration, creating an acceleration, which is changing a speed, whatever. This is not a physics stream, so don't get your physics knowledge from this guy, at least not right now. So change speed x, speed y, we use sine and cosine to make sure to convert between the angle that the starship is pointing and the amount that it should change in the x and y dimension. And this is just some little bit of math that mathematicians invented a long time ago to help us do that, and that Scratch has built in. So we're changing our speed x, changing our speed y, and then if we have pressed the left or right arrow keys, we turn. Easy peasy. We have a star sprite, and what the star sprite does is when the flag is clicked, it disappears and creates 20 clones of itself. And then the clones all have different positions in the universe, different sizes, different colors, and then they are drawn to the screen based on this logic here, this go to universe X minus camera X logic. The camera here is this sprite which handles all of the code for where we draw things on the screen. For telling things where to. Well, at the moment, the camera is actually a really simple sprite. It consists of two things. It consists of this border, which is kind of funny. This border that we have just to hide the sprites that should be off the screen. And then it has this logic where it chases the player around, change the X and Y position of the camera to be close to the X and Y position of the player. But mostly what this camera sprite is just a place to hold two variables at the moment, to hold the universe X and universe Y of the camera itself. The camera is, we're calling it a camera. Really, it's the position of the screen in the universe. So you can imagine that there's a game, there's a starship, there are stars, there's all of these things. There's a giant universe that contains that all these things are the giant 2D plane, and then in that giant 2D plane there's a screen, and the screen is only going to show us a tiny subsection of the universe, and so the screen's going to move around, and inside the screen there's a starship, and the starship can move around inside the screen, and then the screen can move around, and it could even be possible to have the starship be somewhere else and the screen not actually show the player. That's a thing that could happen too. So this little screen here is the camera. And that's our whole program. Now, when last we left, I believe I had noticed some problems. And I had kind of been like, I don't really know. I don't want to think about this right now. I'm done. And debugging on air when you're near the end of the stream is a little bit stressful. So maybe I'm just not gonna. But we really want this player to be moving pretty smoothly. And for some reason, something about this has gone awry, right? Because you can see that, I'm going down and that's great, but then I turn and then suddenly the thing just shoots back to the middle of the screen for some reason, and that's weird and wrong and bad. So let's think about fixing that problem. We know, there's a couple of things we know. We know that, well, let's perform some experiments. If I go exactly right, I immediately get this weird jitter effect. What if I go exactly up? To do that, I'm going to put a 0 there. If I go exactly up, it seems fine, actually. Now, maybe I'm going too fast, and I don't want, I don't want to be able to go away from the camera. And if I go exactly left, I don't have the same jitter effect, but I also don't scroll off the screen in the same way. And then what if I go exactly down? One of the reasons I'm checking that, like, up, down, left, and right is that one of the easiest mistakes to make is with like a minus signs and plus signs. So, it's possible that I could have a mistake that only happened when I was going to the right or going up, and that would tell me that there was a minus sign somewhere that I was missing, or a plus sign. So now we're going to go down, and we'll just kind of marshal our knowledge. So going up and down, we can scroll, we can go fast enough that the camera struggles to keep up with us. Going left and right, we can't. We barely get out of the center of the screen. And going to the right, we get this little jitter. Going to the left, we do not get this little jitter. Unless that's just my eyes. So, I'm gonna just real quick check all of these things and make sure that my X's are lined up with my X's and my Y's are lined up with my Y's, right? Because I wouldn't want to be performing some math on a universe Y that is then changing a universe X. So set universe X to universe X of playership, set universe Y to universe Y of playership. That's just saying make the camera start at the same position of the player. Sure. Go to 0, 0, fine. That's making sure that this border is drawn on the right spot. This go to 0, 0 actually has literally nothing to do with, I'm going to put it there, literally nothing to do with the position of the camera, because everything, once we have the camera working, the only position we ever really care about, kind of in game logic, is always going to be the universe X, the universe position, not the camera position, mostly. Okay, so forever, change universe X by universe X of playership minus universe X times 0.8. So this is saying every frame, change universe Y by universe Y of playership minus universe Y times 0.8. Okay, so that's fine. Universe X, universe Y, universe Y. And what this block of code is doing is it is saying every frame, we're going to figure out how far the player has gotten from the camera, right? So we're going to take the difference between the location of the player here and the location of the camera here, and we are going to move the camera some percentage of that difference, 80% in each dimension, so that it will always be kind of trying to keep up with the player. So that seems fine. One of the other things that I notice, and I'm having trouble really understanding it, but I'm going to do this. I get, like, sometimes I get a really big jitter that jumps me way back to the middle. And I want to do that with the star on the screen. Now, this is not really good software testing. Just have to, as a responsible human, I have to say that. But we may need to make better systems for testing our software down the road. I really just need to get back. All right, I want to go straight up for a little while, and then I want to go straight down for a little while. And I'm not finding the stars again in a way that is a little bit confused. Okay, so I think the problem I think we're maybe messing up that was like way faster than I think we're supposed to go. So I think there's something wrong with our player movement logic. So let's go ahead and look, right? I don't think there's anything wrong with this camera logic. I don't think it has anything to do with the stars. I don't think it's a rendering problem. I think it's actually a movement problem. Yesterday when I was looking at it, I noticed the problem after I introduced the camera scrolling rendering stuff. So I thought it was a problem that had to do with the camera scrolling. But I think actually that the camera scrolling just made it clear that we had a movement problem. So let's go into our physics and check, because physics is where we're changing our, I guess first let's just double check the drawing code for the playership. Go to universe X minus universe X of camera, universe Y minus universe Y of camera. Yep, that seems fine. So what's in our physics then? Change universe X by speed X, change universe Y by speed Y. Every frame what we need to do is change our position by our speed. That's literally the definition of speed and position, so that's fine. If absolute value of speed x is greater than max speed, then speed x, then, okay. Then, if speed x is less, so if absolute value of speed x is greater than max speed, absolute value just gets rid of the negative sign, right? So if we're going negative 400, the absolute value of that is 400. So that just means it's always positive, so we can compare it straight to the max speed, right? Our max speed is always just stored in as a positive number, not a negative number, because that is convenient. So we're saying if the absolute value of our speed x is greater than max speed, if we're going too fast in the x dimension, then we're going to do something about that. We're going to check if speed x is less than 0. We're going to set speed x to minus 1 times max speed. So if we're going negative 400, what is our max speed? Let's just check. Max speed at the moment is 7. So if we're going negative 400 for some reason at the beginning of the tick, actually what we're going to do is we're going to say, let's change that to being negative 7, right? Negative 1 times max speed. If we're going negative 7.1, we'll clamp it back down to negative 7. Else set speed x to 5. Okay, so here's a problem that I see. One problem is that we can get going, that we're clamping down to 5 instead of down to 7 here. This should be max speed, right? This is an artifact of the past when I didn't use this max speed variable and I messed up by not putting it in there. So that probably explains the jitter. That is only happening when I'm going left, right? Because if speed x is less than 0, I'm correctly clamping to max speed. If speed x is, or that only happens when I'm going to the right. If speed x is greater than 0, I'm going to the right, then I'm clamping to the wrong speed, and indeed, that fixes that jitter. That is awesome. We still definitely have a difference in behavior in our x and y, though. And yep, and you can see that jumping. So there's something wrong here. And I think I see it. I think there's a real problem here. So if absolute value of speed x is greater than max speed, so this if statement here is checking if I'm going too fast in the x dimension. This if statement here is checking if I'm going too fast in the y dimension. But look where it is. This if statement is inside of this one. The thing that is clamping down the speed in the y dimension is inside of the statement where we check for the x dimension. So that means we only ever clamp our y speed if we are simultaneously going too fast in the x and y dimensions, right? So that seems to explain this behavior where if I'm going straight down, I can get going really fast and get mostly off the screen. But the moment I move a little bit to the right, I jump back because it clamps down. So that's great. Incidentally, it's really good when you have a bug and you fix it. If you can like super confidently look at your code and say, okay, I see the problem. I see problems in my code. I see problems in the behavior of my program. And crucially, I can see how the problems in my code will cause the problems in the behavior of my program. A lot of times you will fix a bug, or you will seem to have fixed a bug without quite knowing why, and maybe you haven't really fixed it then. Here, we've thought pretty thoroughly, so I'm going to take this if statement, put it down there. Okay, so now I think we probably have everything going smoothly. And indeed, we do. Nice. I am just flying around my little tiny pocket universe here. It seems good. So I want to talk a little tiny bit about this camera control scheme that we made. And then I want to do something with maybe visiting these planets and thinking about how we might think about that. So that's yeah. Here, let me just do this. Okay, 12:30. Fine, no problems. So it took a little longer to do that debugging than I thought, but wanted to be a little pretty thorough too. So that's ultimately, I think, pretty good. Um, so what did I want to do? Oh yeah, I wanted to talk about this block of code here. This block of code is saying the camera is always going to be moving towards the player, but never necessarily exactly precisely getting there. I mean, it will get there, or it will get close enough to there as to be equal in the world of, you know, floating point computer math, where 0.999999999999999 equals 1. It will eventually get to exactly the same spot. But if we had infinite precision, this math would never get the camera to precisely where the player is. But it will, every frame it gets at 80% there. I think Scratch probably tries to run at 30 frames a second. I don't actually know. We certainly could test that. I don't actually care right now either, though, so I'm not going to test it. So it's going to get 80% there every frame. And so the faster we're going, So this percentage really tells us how far from the center the player's ship can get. Right, so let's just play around with it. Let's make this a really small number. Let's make it 0.1. Then we can get this far out of the center of the frame. And if we make it 0.01, let's see how far we can get now. Now the camera is very slow, lagging behind. Okay. Let's make it 0.5. And I'm just gonna go to motion here. I want to show the player's screen position for a moment. I want to make those things visible. So you can see that this number here kind of defines the size of our rectangle. The size of a rectangle for how far we can get in and out of things. So we can get about 15. Right. For some reason, that's 14.8 and that's negative 14.5, and I'm not going to worry too hard. But we can get about 14 or 15. There's like a 14 by 14 square, 15 by 15 square in the middle of the screen that this ship can leave. Negative 15 over here to positive 15. And so we could make this 0.9, and it would be a much smaller square. 8.3. Negative 8.3. Or we could make it, 0.05, and it would be something, pretty big, right? We can get all the way over to 150 and negative 150. So this code defines a kind of behavior for the this code defines a kind of behavior for the player, or for the position of the ship and the camera, and how far off, how far away from the center of the screen the player can ever get. Now, I want to be pretty clear about. I'm going to make this 0.7, I think. I'm going to hit go. Make this 0.7, and that seems fine. And I want to be, as I said, I want to be really clear that this is not really super great camera control code. And actually, writing the behavior of your camera in any game, 2D or 3D, has a big impact about how it feels to play, and your experience of it. And this is not perfect by any means. I would say it's not even that good. But I do think it's a small step up. I personally think it's a small step up from having the player be exactly locked into the center of the screen. So there's that, at least. I think one thing that would improve this, that would be relatively easy, is if instead of defining a square that our player ship could get out of, that if we were instead defining a circle. But to do that, we would have to take these x and y things, and we would have to do some Pythagorean theorem, trigonometry style math to figure out, the distance we were moving, the absolute distance we were moving, instead of the distance in the x and the distance in the y. And that would add some complexity here, and I don't care about it right now. Which isn't to say that I don't care about it in general. It's basically true that nothing in the project will ever be done up until the point when we decide the whole project is done. Because at any point, we might always want to return back to something and improve it in some way. But in order to build the game, we have to build the game. Every piece of the game interacts with, pieces of the game interact with other pieces of the game. So, we have to have there be some camera controls before we make navigation in a reasonable way. So now we got some camera controls in and we can keep moving forward. Does that mean the camera controls are perfect and we don't want to revisit them? It does not mean that. But it does mean that for now, we are satisfied, it's good enough, and we can keep on moving and keep on making new things. Oh, hello, Bryce. It looks like Bryce popped in. Bryce, who is a member of the Scratch team, and with some facts about how loops work in Scratch, the frames per second. So he says, strangely, forever loops have different behavior if you are changing what is rendering on the screen than if you aren't. It renders at 30 FPS if you're changing what's on the screen. Right, yes, and that is a thing that I have noticed in testing as well. And I think, so at the moment, right, we are changing things on the screen here. I think all of our forever loops have a screen change on them. But if we real quick made another forever loop where we said when flag clicked forever, and we made a new variable which we called counter, and we change that counter by 1, if we hit let's set it to 0 ahead of time. So I can hit this counter, and we can see this number is probably just going to get real big real fast. No, it isn't, because is it because I am doing the inspector here? What if I hide that? Variables. All right. No. Maybe I'm wrong. Well, either the experiment I'm performing is an incorrect experiment, or the fact that Bryce has provided is an incorrect fact, or he says it yields if anything changes the screen. So if we had a program that consisted entirely of this loop, or maybe a sprite that consisted entirely of this loop, it would be different. I don't know. Sometimes it's good to experiment about your code. Experiment about how your programming environment works. So that's fine. All right, I'm going to delete this. And that's that. I'm going to move on from this experiment. Yeah, so Bryce says that there's a project that consists entirely of that loop, or, alternately a project that doesn't have any forever loops, any loops in it that change the screen. Then it will run at presumably some like arbitrarily high number as fast as it can, rather than being clamped down to the 30 frames per second. Cool, that's great. I no longer need this counter variable, so I'm going to get rid of it. And move on from that small experiment. And move on to something. Do a quick time check there. Move on to something that requires a little bit of thinking. Yeah. I guess the one thing I might want to add is that maybe about the camera is that if we're going in a certain direction, we the ship kind of moves off in that direction, and then if we stop accelerating, it stays off to the side, and we might. I think a better looking camera would have the camera eventually catch up to the ship, so that at all times the ship was maybe slowly returning to the center. But maybe not, actually. I have no real idea, because there is something that's nice about having the ship off to the side here, showing us that we are drifting in that direction, even if there's nothing else in the background. Now, the other thing that should probably show us that we're drifting in that direction would be like a star field or something like that. That would scroll like a star field of background stars that don't matter. That aren't real stars, that aren't visitable stars. But that's another feature we might want to add at some point. So that's fine. What did I say we wanted to think about? I said we wanted to think about visiting star systems. So let's think about it for a little bit. I haven't really talked about the design of the game all that much. I have mentioned that I want to be able to visit star systems, but I haven't talked about what that means. And so I want to describe that a little bit. There's a little bit of a design in my head that I'm going to get out in the world with talking and typing. And then there's also a little bit of there's more design that probably isn't even in my head yet. But basically what I want you to be able to do is fly your player can fly their ship to a star. If they are touching a star, the game enters solar system mode. Solar game enters solar system mode. In solar system mode, each star has some number of planets. Each star is going to have some number of planets that orbit star. If player flies ship to touch star, to touch planets, go into visiting planet mode. You're going to go into the visiting planet mode. And then I guess there's one other thing about this that I haven't mentioned, which is that in solar system, navigation is full screen, no scrolling. Right, so that's my idea. So we're going to fly our ship over here. We're going to go into the star system, and then we'll see something like, you know, we got this. We're going to have our little ship. We visited our star system. Then we'll go into a solar system mode where there is a star in the center, and then like some planets orbiting. And they might go slowly orbit the star, and we're gonna have our ship here. And the ship can fly around as well. And the ship, you can fly around, but it will move around on the screen. And when you get to the edge of the screen, you will go back into navigation mode. That's the plan. Delete. Don't want that sprite right now. Although I probably do want there to be some sprite. There's almost certainly going to be some new sprites involved in making this feature. But for the moment, there's a couple of kind of infrastructural scaffolding things that we need to do first, right? Because at the moment, we have this like ship navigation physics loop here, where we change our set our speed, and change our universe position based on the player input. And every frame, we're going to be changing our universe position. Now, what we don't want to have happen, we don't want to have a system where we go into one star system, we fly around that for a while, and then we leave, and it turns out our ship has catapulted itself to some entire other location in space, because all the while we were flying around inside that solar system, the galaxy navigation physics loop had been running, and our universe position was changing when it shouldn't have been. So, that's fine. That's totally fine. And we just need to make sure we're handling that. So in this game loop, we're going to need something, in this logic here, we're going to need something that tells us what kind of mode we are in. So I'm going to go, and I think, you know how I said previously, I said that almost all of our variables were almost always going to be what I call local variables, or for this sprite only variables. This one isn't. I'm going to make a variable. I'm going to make it for all sprites, and I'm going to call it game mode. And I'm going to make it all capital letters. The reason I'm making it all capital letters is just to make it obvious that it's a for all sprites variable. So anytime I make a variable that's for all sprites, I'm going to make it all capital letters. And then I don't have to, right? You don't have to. There are other ways to know, right? I can select them, and this will say player ship : max speed, and I can therefore know that this is a local variable only available to the player ship. This one just says game mode 0. I could also, if I go to the star, I have this variable available. So there are other ways to know, but it's nice to have a way to know that this is a global variable just by glancing at it. And that's a convention. And it's one that is, there is nothing there's no direct equivalency between for this sprite only variables and for all sprites variables and the ways that variables work in other programming languages. But there are ways there are things that are similar, and this is a convention that it can be similar. That is similar to the ways we name variables in other programming languages. And more generally, there will always be a convention around variable naming that either your programming language or your own brain or your software development team of collaborators have decided to use. So always follow convention. This is mine. Game mode, all caps. That tells me that it's a for all sprites variable. And let's just think for a moment. When the all right, sorry. When the green flag is clicked, we have a setup, and that's great. What game mode are we starting in? Well, let's say we're starting in Galaxy Navigation. That's the mode we are in, Galaxy Navigation. So, in here, we're going to handle our input. Is our input going to be different based on which game mode we are in? I think maybe no, at least not initially. I think it's fine to be changing a speed. And I think it's fine to be having a thruster force and a turning speed. Now, in the long run, we might have different navigational properties of our ship based on whether we are traveling through the galaxy or whether we are in a solar system, right? Like, it could be the case that we have a hyperspace drive that has its own physics and own navigation, and then we have a sublight drive, and you could upgrade your sublight drive and change your speed inside of the solar system, or upgrade your hyperspace drive and change your speed outside of the solar system, and that they would be separate. At the moment, we're going to keep them the same. Again, acknowledging that we can always jump back into things and fix them and change them later. So I don't think we care at the moment about what game mode we are in when we are handling input. So that's great. For physics, I think we might. For physics, I think we do. Insofar as we don't want to be changing our universe X and our universe Y based on our navigation in the solar system. So we definitely only want to be, we definitely want to say only if our game mode, equals, what do we call it? Galaxy navigation. Galaxy navigation, all caps. Only if the game mode equals galaxy navigation do we want to be changing our universe X and universe Y. If it equals, at the moment there's going to be two modes. Maybe I'll make this an if-else. Do this. And we'll say, if game mode equals galaxy navigation, we're going to change our universe X and our universe Y. Otherwise, if our game mode equals solar system navigation, if our game mode equals solar system navigation, we'll do something different. And I said that we would just, we would move solar systems would be kind of single screen dealios. So we can just directly change our X and Y position like we were doing before. Now, is that, I don't know if that's exactly what we want to be doing in the long run. I don't know if we want to be changing, the speeds might not line up, but this will at least do something, right? What else wants to be different in our solar system versus our our galaxy navigation mode? Well, our stars definitely want to be invisible. Oh. I got ahead of myself. Because there's more stuff in the player that cares about this, right? Because this part here, we really only care. We only want to do this if we are in solar system, in galaxy navigation, right? Because this is drawing us at a position on the screen based on where we are in the universe. So we're only going to do that if we're in galaxy navigation. And I notice that I'm kind of putting these if statements kind of haphazardly in a bunch of places, and I'm just going to say out loud and acknowledge the fact that it may be better to, even if some of the code duplicates a little bit, it may be better to, in this forever loop, have an if-then statement in this forever loop that says, if we're in that galaxy navigation mode, do this. If we're in solar system mode, do that. And separate everything out. Where we put these if statements, it's up to us. It's an organizational decision. The computer doesn't necessarily care. I mean, the computer cares because it will do things differently. But we can make the game run putting these if statements, organizing them in different ways. We just need to make decisions based on what we think will be reasonable and understandable for our own selves and anyone else that is ever working on our project. Now, that said, I picked some decisions, so I'm going to go with it. Every organizational code decision that we make, we should be prepared to revisit if it starts to feel clunky or cumbersome. And the moment it starts to feel cumbersome, we should revisit it and change things, rather than kind of living with the unpleasantness for a while until we've built a creaky, rickety house of cards that collapses under its own weight. So, all that said, I think that's everything in the player ship that cares what game mode we're in. In the stars, we don't want the stars... We want the stars to disappear if we're not in galaxy navigation mode, and to show if they are. So we're going to need another equal sign. And I'm doing this pretty haphazardly and pretty sloppily because I think we will ultimately do that we will generally make some slightly different decisions about how we organize this stuff. But for the moment, I'm just going to do this. What about the camera? Does the camera care about anything? The camera only needs to do this if it's in galaxy mode. Although it doesn't really matter if it's not. Oh, it's not called galaxy mode. It's called galaxy navigation. That was a problem. That wasn't going to work. Navigation. What about here? This is also galaxy navigation. Navigation. And then player ship. Did I write mode anywhere? No. Okay. Cool. So having done all that, we should be in the usual, wonderful, regular, everyday old position where we've done a bunch of work and our code has not changed in any way. But we now have this variable called galaxy navigation. So let's do something. Let's have it so that if the player touches a star, we go into solar system navigation mode. I'm actually going to put this logic inside of the star rather than the player, just because there's less code in the star at the moment. The player's controller code is getting a little bit complicated. And actually, I think maybe we don't necessarily... a bunch of things need to happen when we switch modes. So I don't think it necessarily matters which sprite triggers the initial switch. So let's have every star, if we're in galaxy navigation mode, let's have every star check if it's touching the player ship. If touching player ship. If it is, let's switch modes. Set game mode to solar system navigation. So let's just see what happens. That's great. It's not right exactly, but it's doing, I mean, it's not complete. It's very, very far from complete, but here we are. Have game mode. It's very funny, incidentally. I find it extremely difficult not to point at my screen to show you things, and it's very unhelpful. So I'm continually gesturing forward to point at my screen, and then in the middle of it, remembering that I need to use the mouse. All right, so game mode, galaxy navigation. We are in galaxy navigation mode. I'm going to creep on over to this. When I hit this star, we're going to enter solar system navigation. All the stars disappear. They all hide. And now my position changes directly instead of my universe position, right? So let's go ahead and let's go then back to the player ship, and let's tell the player ship that if it touches the edge of the screen, then change the mode back to galaxy navigation mode. So this is going to be here. If game mode equals solar system navigation, we directly change our X and Y. And so then let's do some checking around stuff. Is there a downside to just checking if the player is touching the camera? Meaning this outer edge here? I don't think there's a major downside. So let's just say if the player is touching the camera, let's change our game mode. Set game mode to galaxy navigation. Hit go. Okay, now I'm in a solar system. And then I'm going to go back out here, get to the edge, and right. So there's a problem though, which is presumably that I am I can go to this star, and then I'm in solar system mode, but it's very but I'm immediately, you can see I'm immediately appearing in galaxy mode and touching that star again. So that's fine. It's not good. Let's fix this in a way that is not right. Oh, I guess let's just do this. Yeah, let's say well, I don't know. Whatever. I was thinking, trying to figure out where we can put like a wait until not touching star. This is also just a perfectly fine place to leave off, because here I'm gonna, right. I can enter if I enter from the right here, and then I leave from the left. I can go back into galaxy navigation. This is not an ideal situation, but I'm very definitely successfully switching between these two modes. I think I'm very definitely over my hour, so that's fine too. So let's see. Let's wrap up. All of this galaxy navigation, game mode, solar system mode stuff is kind of sloppy, but it was a way for us to start to think about this problem, and we are now going to have to think about it a little bit harder. One problem that I didn't even think about is that this problem of leaving the star system and touching the star again. So we're going to need to solve that, and in order to solve that problem in a really good feeling way, we might need to reorganize some of our code, and that's just fine. That's great. That's why we're here. That's why I'm doing this all live, and not, prepping it ahead of time and coming up with a good system and then showing you that system, because I want to show you the thinking, the messing up, the breaking things, the thinking about how to fix them, the being confused, all that good stuff. So maybe that is makes for bad TV. Maybe it doesn't. I don't know. It's up to you. We are done for the day, so let's wrap up with our kind of cleanup and record keeping stuff. So I named this episode ? That's a bad name. What is a good name? Bug fixes bug fixes and solar and new game mode. That seems fine. Bug fixes and new game mode. A little bit cryptic. What is the new game mode? Or is it like new game mode, like new game plus? It's a mystery. You'll have to watch to see. We can save. We can save. Saving projects. We can go to my stuff. We can see inside. And we can't... No, I didn't want it. Something is wrong, because now it says join Scratch. So we're definitely having some web connectivity bugs. I would like it if everything was working well and I didn't lose any progress, lose any data. I don't think I have. Everything looks fine. I'm gonna click share. What am I gonna... Okay. Left, right, thrust, up arrow key applies thrust. What are we gonna say? Today we fixed a starship control bug and added a new feature where when you fly to a star, you go into a new Solar System Navigation game mode. That mode isn't yet written, so the game is currently in a kind of broken state. Great. I think that just about covers what we did. So we'll call it good. Okay. So, thanks everyone. I've been Will. This has been built from scratch. You can look at the code for the project on the Scratch website. If you search for Built from Scratch as a username, you can find all the code here. You can see archives of the videos on Twitch and also on YouTube. There's a link to the YouTube somewhere, maybe. You can search for it. Search for Built from Scratch with underscores. You can probably find it. There will be links to the YouTube somewhere. I'm trying to figure out where to put links to things. I had been putting them in the Scratch profile and the instructions for the videos, but then I realized that was probably a violation of the Scratch terms of service, so I took those links out because Scratch website quite reasonably has some very reasonable opinions about what you can and can't link to and how Scratch can be involved with other external websites. Yeah, I'm trying to sort that one out. I haven't fully done that yet, but at the moment the videos are all also archived on Twitch. I think that will end in like 10 days, or I think the videos will only be archived for 14 days. So, I've got some time to sort the logistics. I am uploading them to YouTube. I don't know if there's a good spot to give you the link, and at the moment, it doesn't have a name. The channel doesn't have a sensible URL because you need to have like a bazillion followers or something to get a good YouTube URL. So that's where I'm at. Thanks for watching. Thanks for tuning in. And as always, you can, if you have any thoughts, suggestions, comments, or anything else, you can also send me a message on Scratch. And please, you can also jump into any of the code and remix it and make your own version. That would be super cool. I would love to share. I'd love to see that and share it with others. And that's it. Yeah, thanks for watching. Special thanks to Bryce for tuning in with some of his under the hood Scratch knowledge. It's always awesome to hear from him and have, to get his perspective, because he actually works on the Scratch code base and knows a lot about it. And so that's super, super cool. All right. Thanks everyone. And see you all later. Bye.